Hey, this is Dr. Drew Rubin. Welcome to another episode of Disruptive Pediatrics brought to you by ChiroSecure, the amazing malpractice insurance company. Um, what I'm going to do today is share with you some really groundbreaking stuff, stuff that is kind of being uncovered in the last bunch of years regarding uh, brain hemisphericity and lateralization and how important it is in a pediatric practice. So let's go to the slides. Thank you. And first off, what I want you to understand is there's been a controversy about hemisphericity and lateralization for a long time. People saying there's no such thing as a left brain, no such thing as a right brain. It's just one brain, and blah blah blah. And what I'm telling you is, after doing research, especially with Dr. Melillo, doing research, realizing there absolutely is a left brain and a right brain. Now, here's where the problem is. The problem occurs when you start talking about, I'm a left brain person, I'm a right brain person. That's not exactly what's happening, right? You might have more left brain traits, more right brain traits, etc. But there isn't. And I think this is where in the pop psychology it got all wrong. Is they were thinking that you're talking about, oh, this is, you're like, only my left brain's working or only my right brain's working. That's not how it works. Obviously, both sides of the brain are working at the same time. What we're seeing, though, is there's absolute lateralization, number one. And number two is that asymmetry in our brains has an amazing function, makes us who we are. Um, we have the most asymmetrical brains of all the animals on the planet, which is why we're able to do the things that we can do. Um, but herein lies the problem. All that asymmetry can create a problem. And that's what we're seeing a lot with the kiddos on the spectrum, with autism, with ADHD, with learning disorders, or a lot of these issues. I just had a person come in with a tic disorder, and it was really a lateralization kind of issue in her brain. And there's a lot of this sort of stuff. So what we need to do is understand what this is. So let me start talking about this. So Dr. Miller mentioned this concept of the lateralized brain, and being a faculty member at Life University, what am I going to do? I'm going to get a textbook. That's like, I hear something. I'm either going to get a research paper or a textbook. And usually my first thing is, I love textbooks. I'm very intrigued by textbooks. And these two fellows from Europe are the kind of premier brain asymmetry people on the planet right now. And they wrote this textbook, which I highly recommend if you're interested in reading textbooks. And it's very readable also, called The Lateralized Brain. And this is something I didn't know. Did you know this? Did you know that 8-day-old embryos already are expressing asymmetry? I had no clue. I thought this asymmetry was something happened maybe towards the end of your gestation period, but it actually starts 8 days in the embryo, at the 8th day, where there's this sort of circular formation because of the cilia within the embryo, and it actually shunts more like stuff onto, and you can see in the picture in the PowerPoint, you can see under letter A, you can see there's more like stuff on the left hand side than on the right hand side, because this node, which I don't want to go into, but this node that from these genes are actually creating this leftwise asymmetrical expression. And this is interesting too. So, like, okay, only human beings have asymmetry. No, it's actually started a zillion years ago. So from the same authors, they did a retrospective study on like all mammalia and all animals that have ever existed. This is a trilobite. I don't know about you, but when I was a kiddo, I was super interested in dinosaurs and stuff, and I collected these things. Um, and here's a trilobite, from 500 million years ago, that has a bite out of it from its right side, indicating that whatever was attacking it was actually coming from the left, right? So that because that's the left. So even 500 million years ago, there is as the antecedent of this asymmetry that's going on. And then they also did a study, not these guys, another author did a study of 50 centuries of handedness. So in other words, this is a brave study, probably done with AI, because I don't think you can just do this yourself. Looking at all art, from like the handprints on the walls in the caves in France and stuff, all the way through the modern era, and saying how many people in these particular pieces of art, sculpture or paintings or cave art or whatever, are using their right hands, and they found 90% were using right hands in their depiction of using swords or painting or whatever else they're doing. They were using 90% of them were using their right hand. How interesting. Now, but this also is an interesting thing because most animals, excuse me, most animals have what they call near symmetry around the mid-sagittal plane. So, because this is what people get confused about, like obviously my two hands look relatively the same, and if you split my face down, it looks relatively the same. Uh, you split everything down, it's relatively the same on the outside. On the outside, it's relatively the same, and now the bone structures might be relatively the same, but when you start digging into the thorax and abdomen over here, and the brain, not relatively the same anymore. So what happens is the external symmetry is very efficient for us to be mobile and us to maneuver around things, to walk around rocks and trees and what have you. But the internal stuff, the brain and the internal organs, they're not very symmetric. And that's because there's this pressure, as the authors have said, towards asymmetry to package and make it more efficient, right? So if you think about what we look like on the inside, it's not exactly reflective of what's happening on the outside with our symmetry. So what happens is when we add complexity, we add asymmetry. So the more complex a being, whether you go from an amoeba to a fish to a lizard to a mammal to a human, you start adding complexity, you have to create more and more asymmetry. Because now, in order for the brain, forgetting about the rest of the organs, but for the brain to do what it has to do, it must have two different areas to work on. So in other words, instead of everything just being, like having one area, you're going to have two different areas, a left side and a right side that relate to that area. For instance, Broca's, right? Broca's might be more left-sided, but there is an area on the right-hand side that relates to Broca's too, right? And it's not that it doesn't relate to the same language center, it just relates in a different way, right? So this way we have like this part of Broca's creates certain things and this part of Broca's creates other things. And this is another interesting thing that I remember learning a bazillion years ago when I was in neuroanatomy, in chiropractic school. But there's this counterclockwise brain torque. So their brain it's not a circle, right? It's actually kind of counterclockwise shifted a little bit like this. So if, like it says over here, the right frontal lobe extends farther forward than the left occipital lobe extends further back. So you have this shift like this. And why are all these things important? Because these three forms of brain asymmetry have different functions. So some of the functions are to create handedness, like left versus right hand. Some of them are to create language lateralization, like obviously language is more lateralized to the left hand side. Some of them are for different structural things for protein distribution. Some of them are for connectivity distribution issues. So there's different reasons for this asymmetry. And so there's more asymmetry on one side than another for certain things, for certain functions of what our body does. But here's the interesting thing, and this is what's gonna really get you, and especially start doing some more research yourself, is that what they've done in studies is they've shown that 72% of people are right-handed, of neurotypical people, but with kiddos on the spectrum and adults on the spectrum, only 28% are right-handed, or they are neither dominant left or right. Wow. So that means that like most people, neurotypical people are right-handed, but kiddos who are on the spectrum either are left-handed or have a mixed dominance. Wow. What does that mean? Right? And what that means is that hemispheristically based care is very important. Most care in a chiropractic office, especially, or OT or PT office, is done very bilaterally. And the suggestion that this is making is that is not exactly the way we want to go. So autism shows different dominance profiles, right? There's several studies have shown that ASD autism spectrum disorder, the typical leftward dominance in language system is frequently reduced or even reversed, so that the patients show no or actual rightward asymmetry. Wow. Right? So what that shows is that the left Broca's are supposed to be on the left-hand dominant in a neurotypical person. In a kiddo who's on the spectrum or adult on the spectrum, they might either have no symmetry or maybe right Broca's on the right may be dominant. Wow, this is big. This is really big. And so once again, the authors of that textbook, they wrote this particular article, Clinical Implications of Brain Asymmetries, and this is what they said. Neuromodulation has become a viable treatment option for a wide array of brain-related disorders, including mood disorders, chronic pain, neurodegenerative disease, and epilepsy. Let's add autism and to that little list there. The working principle of neuromodulation is to suppress or enhance activity within a targeted brain region or network to rectify dysfunctional neural activity. Many established neuromodulation protocols are lateralized. Wow. Wow, this is huge. This is really big. What does this mean? This means that what we need to do in chiropractic and in physical therapy and in occupational therapy when we're working with these kids is we need to figure out what's going on with that particular child, like where are they lateralized? Are they right dominant or left dominant? And then do something to affect the weaker side. So as an example, if we have a kiddo who's got a right deficiency, we're going to adjust left side and vice versa. We're going to give exercises skewing things more to the weaker side, right? So if they have primitive reflexes that are retained and they're retained on both sides, but if they have a left deficiency, then I'm going to adjust them on the right side and have them do more exercises on the right side to affect this. This is what we're going to talk about next time. So it's like a little teaser. Get you excited about this. The next talk that we do on ChiroSecure is going to be the part 2 of this to explain how we look at this and how it can affect kids in a really huge way. So you guys know, hopefully, that I speak for the ICPA. So I'm doing a lot of talks. We've actually changed our talk to be much more brain-based focused for this particular year. I'll be also speaking in 2 different virtual seminars in April and December about tongue tie. There's been a big controversy about that, so we're trying to address it through the ICPA. So please join me in that. Here's the link and the QR code. We've just published our 600th episode of ChiroCast, so I'm super excited about that. Most podcasts hardly even last like 50 to 100 episodes, and 300 episodes is less than 3% of all the podcasts out there. So 600 is really cool, and thank you so much for being great listeners out there. As always, I want to thank ChiroSecure for hosting Disruptive Pediatrics. I think this is so important for us to constantly focus on what it is that we can do to help our kiddos. So thank you so much again, ChiroSecure, for being there for us, and I'll see you next time.
Today's Pediatrics show, Look to the Children, was brought to you by ChiroSecure.